In today's lesson, we're going to be using our knowledge of trig formula to find the unknown side lengths of right-angled triangles. So we've got three examples here and we're going to work through all of these. First thing we do when we get a triangle like this within a problem is identify the elements of the triangle we know. So when we're talking about the angle here, we can label this side here of x as the opposite. And remember, the angle opposite the right angle, or the longest side, is the hypotenuse. So from here, we need to determine which one of our trig formulas we're going to use. If we've got the opposite and hypotenuse, it means we're going to be using our sine rule. So as a starting point, let's write out what the sine rule is. So it's sine theta, so whatever the angle might be, equals the opposite over hypotenuse. So what we've got is a triangle which we've labelled, so we can now substitute the values in. So the theta in this situation is 50. So sine 50 degrees equals the opposite, which we don't know, so we're going to label that x as it's labelled on the triangle, and our hypotenuse is 17. Now we should be familiar with rearranging the formula, so we'll just go through it quickly. We can take the 17 across to the other side, so we have 17 sine 50 equals x. We'll make x the subject, just popping it on the left. 17 sine 50. And then from here we plug that into our calculator. So let's just bring our calculator up. Hopefully you've got a calculator close by. And so from here we're just going to plug it straight in as we've got it written on the line. So 17 times by sine. Now the sine button is just above the 9 here on this Casio. So we go sine and then enter our degrees in. 50 equals. Now, as a general rule, we're going to round to 2 decimal places unless we're told otherwise. So the answer here is x equals 13.02. And remembering our units, so in this case we're talking about metres. So that's our first example done. Let's go on to the second one. Again, we're going to use the same method of labelling what we know. So we have the hypotenuse, the longest side. And this time our angle here means that this side length here is adjacent. So again, looking at our trig formulas, we have an adjacent and a hypotenuse, so we're going to be using the cosine rule. So just stating what that is, cos theta equals a adjacent over h hypotenuse. And again, we can just go through and plug out values in. So cos 27 equals the adjacent, which is y over h, 7.9. Again, we should be familiar with doing this, so I'll just quickly jump ahead. Now, normally as well, one of our conventions we would be trying to line up our equal signs underneath each other. So as you're going through this, just try and do that as you go. So we're going to plug that into the calculator. So again, just straight off the line, 7.9 times by cos, so that's just next to the sine button, 27, close bracket, and rounding to 2 decimal places, we end up with 7.04. So y equals 7.04, and remembering our unit, which is metres. Okay, so moving on to our last example here. Again, we're going to identify the component parts. Moving on to the last example here, we're going to identify the component parts. So we have the angle. So this time we're talking about the opposite, and it's not the hypotenuse that we've got labelled here, but the adjacent angle. So we've got the opposite and adjacent, so we're going to be using tan. Just make a bit of room over here. So again, we're going to write out our formula. So we have tan theta equals the opposite over adjacent, and we can substitute our values in, being tan 31 equals our opposite z over adjacent, which is 46. And again, this should be something we're familiar with. What I'm going to do this time is just put the z on the left hand side straight away, and that way it becomes the subject. Just one less line of working out. All I've done there is just reorganise it. And then we go through and plug that into our calculator. So 46, again the tan button's on that same line just next to cos, so times by tan, 31, close bracket. Solving to 2 decimal places, we've got 27.64. And our unit this time is millimeters. So there we have it. That's how we solve our triangles or unknown side lengths using trig formula.